Okay, so here we will do some problems from the book 4.1. This is about related rates. So what we have is the baseball field, and these are the names that you probably already know better than me. The question 42 asks for a batter hits the ball and towards the third base at 75 feet per second and runs toward the first base at rate of 24 feet per second. At what rate does the distance between the ball and the batter changes when 2 seconds have passed? Okay, so let us start with 42 here. So what we have is that we have this field here, and then the ball is going on the direction of the third this way. So this is the ball, and then the batter is running this way. What we know is that the speed of the batter is 24 feet per second. I won't write the units here. And the ball is has the speed of 75 feet per second. The question is that how fast the distance. Oh my God, do I have the charger here? Yes, I have. Okay, so let me. Okay, so the distance of these two will be something here. As always, we start, identify the quantities. So the first thing is that while the batter is running away, running to from the base to the first base. So here, what we call this thing, so the distance of the batter from the base. Also, we have distance of the ball from the base. That's changing. So one of the key points when you're identifying the quantities are that the quantities that are changing are definitely what some of the quantities you will use in your problem. And the quantity that we are looking for is the distance between the ball and the batter. Yes, these are all homes. I'm writing base, so this is home, home, and then distance between the ball and the bat. So these are at least the three things that we can see. They are changing, so we have to introduce into our problem. So then the second thing is that assign variables for each one of these guys. For example, I can go ahead and set this one X, this one Y, and then this one here L. Okay, so X, Y, L. And as you can see, there is a good relation between X, Y, L. This is Pythagorean. So this is the third step, which is find the relation between the variables. Okay. Here, what we have is by Pythagorean theorem says that L squared plus equals to x squared plus y squared. Yes. What else we know? We know that dx dt, that's how fast the battery is running, is 24. dy dt is 75 feet per second. I don't write the units. And then the question is, what is the LDT? Very nice. So when you get to this point, you have done the modeling and you're done with the wordings. What you need to now to care for is, okay, I have a mathematical problem, and now I want to find the solution for that. And if there's an equation, and we have dx, dt, dy, dt, we want to find the LDT. So now finding the relation. The relation among the rates. Okay, this is the equation. We differentiate in the related rate. We differentiate with respect to the third variable, usually the time. So d dt of L squared equals to d dt of x squared plus y squared, and this is 2 dl dtl, generalized power rule. This is d2 dx dt times x plus 2 dy dt y. And then if we look at the quantities that we have values for, dx dt is 24, sorry. And it's multiplied by 2. I don't know what is x, so let's just keep it for a second there. 2 times dy dt is 75. I don't know what is y. And then I am looking for dl dt, so it will stay there. And then from that, I want to also know what is L. So that is the third thing that I have to know based on the information. Let's go back to the question. The question says, find how fast that distance changes after 2 seconds. That's a key point. See, the runner, the batter, runs with the speed of 24 feet per second. If it passes 2 seconds, so after 2 seconds, what will happen is that x, the distance between the batter and the home, is going to be 24 times 2. That's how fast he runs, yes? Times at 2 minutes, so this is 48. How about y? Well, the ball is flying away with the speed of 75 after 75 feet per second. After 2 seconds, it will be 150 feet away from the home. Okay, so I know now what to put here, what to put here. How about L itself here? Okay, so this is where the original equation is going to help us. So if you consider that the relation between x and y and L, now you can plug in there. L2 is going to be 48 squared plus 150 squared. And from there, well, L, we are taking always to be positive. The direction is chosen such that it will be positive. So this will be 48 square plus 150 square. Okay, nice. Then we have all the information we need. First of all, I can cancel these all 2's there. Yes, each term has the coefficient 2, so I can cancel it. And then from there, I can conclude that dl dt is equal. everything divided by this L here. So it is root of 48 squared plus 150 squared. And in the numerator, I have the numbers are all here. Well, actually, I cancel twos. Oops. I cancel these twos. So what we have is 48 times 24 plus 75 times 150. Well, it is a strange number, but can we simplify? You don't need to simplify. And if I leave it like that, this will be how fast the distance between the batter and the ball will change. Okay. So that's the answer for the question 42 of the book.